In this lecture, I will speak about the pulse code modulation. So in the previous lectures we have covered PAM, PPM and PWM. These were the analog modulation techniques. Now I am talking about pulse code modulation, that is the digital modulating techniques. Okay, information is transmitted in the form of code words. So all the information will be transmitted in the form of code words, and PCM output is in coded digital form. Okay, let's speak about the block diagram of it. So the first block, okay, this is my first block, second block, third block, fourth block, and then last one is fifth block. So I'm writing what are the, so this is low pass filter, this is sample and hold, this is quantizer, this is encoder A to D, and this is parallel to serial converter. Okay, let us convert it. Convert, encoder A to D, convert, and this is parallel to serial converter, convert. Okay. So let me write it again. Parallel to serial converter. Okay. So these are basically the blocks, and there is another block which will be here. So this block is pulse generator. Okay, so this is pulse generator, and okay, let us just finish these arrows. So obviously the first one is, it will be xt, the message signal, then this will pass through sample and hold, this will pass through quantizer, this will pass through encoder, this will pass to parallel to serial converter, and the final one will be connected through here like this. And now there are some points I need to write. So here I am getting PAM, here it will be quantized PAM, and this one is digitally encoded. Okay, and this is the final output. Okay, now I will explain you. This is the circuit of PCM transmitter. PCM transmitter. Okay, so how I will explain is, what I will do, I will write the function of each blocks here, then I will explain. So LPF, low pass filter. So what it will do, it will, so low pass filter, I am just doing it. So it will band limits, and second is eliminates possibility of aliasing. Okay, I've explained you what is aliasing in the previous, the first one. Aliasing is basically when we were doing the sampling theorem, so aliasing is this one. Okay, when it is an overlapping. So this is basically the aliasing. Okay, now next block is sample and hold. So what does sample and hold does? It will give flat top PAM. Okay, pulse amplitude modulation with a flat top. Next block is quantizer. So what does the quantizer does? It gives the quantized PAM. And the last one is encoder. What does the encoder does? It will do the analog to digital converter. Okay, so it is passing through here, it is passing through here, and it is passing through here. Now, then after encoder, each quantized level is converted into n-bit digital word. Okay, and then it will goes to parallel to serial conversion. Okay, so this is basically the thing you need to remember. Okay, so look here. So the first point is LPF. So LPF, what does it doing? Band limits eliminates possibility of aliasing. This is the function of L. Then sample and hold, flat top PM. It will give the flat top PM. Okay. And then after this, it passed through the quantizer. Then I will get quantized PAM. Then it passes through the encoder AD. It will do the analog to digital conversion. And then it will pass through the parallel to serial converter. And then the pulse generator. Okay. So this is basically the thing. Now, okay, I have used the quantizer. So what is the function of quantizer? So quantization process, what is the quantization process? Quantization means basically rounding off, okay, or approximation. So we are transmitting of data using code words, as we are transmitting data using code words. So if we map all the samples, bandwidth will be large. So rounding off all the samples. Okay. So suppose this is my sinusoidal wave. So if we map all the samples like this, that means the bandwidth will be very large. So I'm writing here, if we map all the samples, then bandwidth will be large. So we will take rounding of all the samples. That's why the quantization process is done. Okay. Now we need to make the waveforms. So how to make the waveforms? Very, very simple. I'll explain you. So I'm making like this because so that you understand how to do the waveforms. Okay. Okay. So first of all, there is a continuous time signal like this. You can make any form which is continuous. So I can mark it here. This is continuous time signal. Okay. Or I can say this is the modulating signal. Okay. Next is your pulse generator. So I'm just giving the constant pulses like this. I can just make the constant pulses. Okay. So let us say this is the pulse generator. So, and this is basically our carrier signal. Okay. After the carrier signal, you can see the pulse generator, and after the carrier signal, what is there? The PAM output. We are getting the PAM output. PAM output, you know, it's just the same signal. It's just the same signal I am getting, but I will make it dotted. Okay, I'm just doing it dotted because we need to make the PAM. So how to make this PAM? Now I will just do this like this. Okay. So this is my PAM signal. Okay. So I'm marking it. This is my PAM. And next is quantized PAM. Okay. How to do this quantized PAM? What I will do, I will create the dotted line on every rising edge. So this is the dotted line. This is the dotted line. This is the dotted line here. This is the dotted line. Dotted. 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 On, remember, I am doing on the rising edge, not the falling edge. Okay. So till the next rising edge, what will means actually it will just depend on the output, what output I am getting. Okay, we are just rounding off. See the quantization process, we are rounding off. So what will happen is, let me just do with this pen. Okay, so how to explain it? Okay, as you can see this one, so I'm starting from here and I'm doing like this. Now can I see this and this are basically the same height. Okay, so what I will do, I will just take the round off. So I'm just increasing the amplitude and till this point I'm rounding off. So that means it's the quantization process. And now this and this are of the same height. So what I will do, I'll just decrease it and I will round off till this point. Okay, and then again I am just making it high and I am rounding it off. Basically they are of like different height, but if they are approximately same, then I am using the quantization process. Okay, so I can say that this is my quantized PAM. That means I have round off the values. I hope you understand that. And now if I need to put the answer, then it is 0 0. This is 1 0. Let us say this is 1 1. Let us say this is 1 1. And again now it is 1 0 1 0 1 0. Let us say this is 1 1 and this is 1 1. Okay, and this will pass through analog to digital converter, and then this will give the binary output. Okay, it will give the binary output. This 0 0 and 1 0 is the binary output. So this is all about the transmitter. Now if I need to do the decoder, so I'm writing decoder or receiver of PCM. Okay, so it doesn't require any explanation. I'm just making the block diagram so you know what is the block diagram. So this is the input here, this will goes here, it goes here, it will goes here. Okay, so I'm writing inside the block, this is the regeneration circuit, series to parallel converter, next is decoder, D to A, digital to analog, and next is low pass filter. Okay, and here this is basically PCM plus noise. So there is basically corrupted PCM signal. It will goes to regeneration circuit. So regeneration circuit will give clean PCM. Okay, and then it will convert to series to parallel converter, and from this series to parallel converter basically a pulse generator will also be connected, as in every circuit we have done the pulse generator, and this pulse generator will goes to the series and parallel converter together. And then after this, from here we will get the n digit PCM output, and from here we will get the quantized PAM. So this is basically the receiver of PCM. So you just need to remember the block diagram. Okay. And the last topic is advantages of PCM. What are the advantages of PCM? So the first one is very high noise immunity. Second is due to digital nature of the signal, repeaters can be placed between the transmitter and receiver. Okay. So what is the function of repeaters? The repeaters actually regenerate the received PCM signal. This is not possible in analog systems. So what does the repeater do? Repeater further reduces the effect of noise. Okay. So this is the function of repeater. And the third one is, it is possible to store the PCM signal due to its digital nature. It is possible to store the PCM signal due to its digital nature. Okay, so these are the advantages of PCM. You need to remember all the advantages nicely. So repeater, and the last one is it is possible to store the PCM signal. I'm just placing on here. Okay, so these are all the advantages of PCM signal. And after advantages, what is the next topic? The disadvantages of PCM. Disadvantages of PCM. So the first one, the encoding decoding in quantization circuitry is very complex. So always remember, when it comes to disadvantages, the circuit will be complex. So the encoding, decoding and quantization circuitry of PCM is very complex. And second one is, PCM requires large bandwidth as compared to other systems. Okay. So these are the disadvantages. So if you forget the disadvantages, suppose in exam the question comes, so always remember, circuit is complex, and the second one is the bandwidth is high. Okay. And the last one is applications. Where does this applications of PCM? Next, in telephony and in space communications. Okay, so these are the applications of PCM. So these are the topics which are very important. You need to remember all the block diagrams. Okay, this is disadvantages and this is your applications.